going to be talking about the law of cosines today. You see, I've written several formulas, actually quite a few formulas on the screen. I want you to be very aware of, I've really only written two formulas. If you see, this is the basic law of cosines. A squared minus a squared equals b squared plus c squared minus 2bc cosine of a. You have to be very careful. These formulas are interchangeable in terms of the letters. The way I'll remember it is the two letters that are here also repeat in this scenario. If I start with an A outside, I end with an A. If it's with a B, it's a B. So the outside letters are the same and the inside letters are the same. If you take this equation and you rewrite it in terms of the cosine of A, then this is what you get. So really it's one big formula rearranged or rewritten to represent the letters or the particular need for the problem. When do you use the law of cosines? Law of cosines is always used when you have one of each of the letters, one A, one B, one C. I don't really care how many, or is it an angle, is it a side? That's not really relevant in this problem. I just want to have an A, a B, and a C. If you can look at that and see, well, I've got each one of those, then it's automatically law of cosines. Now, mathematically, that translates into side, angle, side, or side, side, side. Okay. Remember, if you compare this back to the law of sines, we had to have a matching set. I needed an angle A and a side length A, or an angle B and a side length B, or the same thing for C. And that translated into several things like angle, angle, side. It translated into the side, side, angle. That was when we had the ambiguous case. Really, the only thing that you have to remember is if I got a matching set, it's law of sines. If I have one of each letter, that's law of cosines. Let's look at an example to start with. We have a triangle here where you see triangle ABC is located here. You have side length C is 42, angle A is 39, and side length B is 21. I've gone over and I've applied the law of cosines to the problem. I needed to find angle A or side length A first. In this case, I don't really have a choice. In this problem, because we are working with my angle as given, I'm going to have to use the law of cosines to find the side length of the given angle. This is a side angle side problem. You can try to work this out in a different way, but you'll quickly find out that it's not possible to do it any differently. So that's what you've got to work with. I plug it into my law of cosines. And in fact, I actually type it directly into the equation or my calculator just like this, being very careful. I get that answer, that's equal to a squared. I take the square root of both values, and there you go. You've got your a is equal to 28.9. All right, the next step, since I've got all the angles, all the side lengths, I need to find the rest of I need to find at least one angle, and then I can subtract from 180 to find the last angle. So let's work, since I've got 21 already given to me, I'm going to work with that one. Let's find angle B. So I'm going to take the formula right here. I plug all my values in. I've got all the side lengths. Plug it in. I work it out. And I get my B value is equal to 27.2 degrees. And that's here. Now, I could use the law of cosines again, or I could even maybe switch to the law of sines. But be careful when you switch to the law of sines. If you do that, there is a risk of accidentally getting into the ambiguous case without ever realizing it, and you might come out with a triangle that's invalid. And so the way that you can check that is just to add up your angles. Make sure that the angles add to 180. Okay, otherwise you could have a problem, and you may have a triangle that really can't be a triangle. So you see here, I went ahead and finished it out. C is going to be 113.8 degrees, and that finishes up my triangle. The last part of it was to find the area. Here we have a new formula. This is called Heron's formula. This is a great formula because it simply works on the sides. I don't need to know any angles for this. If you remember back from the law of sines, you've got a couple of formulas that work with two sides and one angle. Here, it's all three sides. Okay, so let's see. And if you plug all that in, S, there's kind of a mini formula built into this one. You've got S times S minus A. Well, S is actually the half of your perimeter. So if you add the sides up, divide by 2, that gives us S. And you can see this working problem here. All right, so the formula, plug in 46 since that was my half a perimeter. 46 minus A, 46 minus B, 46 minus C. Take the square root of that value and I get 280.5 units squared. And that's how I work with the basic formulas for law of cosine and sine. This particular example is the side angle side example. Let's look now at the side example. So you've got this triangle. I've been given all 3 sides. So I'm going to have to find 2 angles, and I can subtract from 180 to find the third one. And I've just went with the law of cosines. It's pretty easy to set up. So 9 squared plus 5 squared minus 8 squared over 2 times 9 times 5. Get that value, and I take the inverse cosine, right, of 0.4667. When I do the inverse cosine, oops, that should be not cos of C, but actually C. Okay, so now you can see the correct answer. C equals 62.2. A equals 84.3 degrees. Now, to find the third angle, of course, we add them all together, subtract from 180 to find that my last angle is 33.5 degrees. Going back to our Heron's formula again, to work this out, I do the same thing again, and I get my answer for my area to be 19.9. With the law of cosines, it's not nearly as confusing as the law of sines. This law of cosines, it does not have an option for getting confused or having more than one answer. It's one answer. What you see is what you get. Make sure that you know how to distinguish between the formulas, and make sure that you know Heron's formula. Very useful formula for using the law of cosines. Very straightforward. Just be careful about typing it into your calculator or order of operations. A lot of times people want to add these numbers together and then subtract the product here. That is not allowed. In order to do this one correctly, I have to multiply all of these numbers, 2 times 21 times 42 times cosine of 39. Then I'm allowed to combine them together. Okay, be careful about that. And that is the law of cosines.